This video we're looking at power. Previously you would have seen the formula power as energy over time or work done over time. So sometimes you will see the W for work being energy converted. An alternative to this is P equals I times V, and I'm not really going to prove it to you except indirectly with these units. I'm just going to tell you what it is. So P is power, as of course measured in joules per second or watts. What is the unit of power? I is current, measured in, let's just write these, so joules per second. I is current, measured in coulombs of charge past a point per second, and times by V, which is voltage, which is measured in joules per second. So it's all these rate things going on, the rate of energy carried, which is voltage, and the rate of current flow. It gives you the rate of power when you multiply them together. P equals I times V. Now there's, I will do the units thing. Comparing these units, joules per second, coulombs per second, and sorry, I've mixed this other one up. Joules per coulomb. You might even know where I'm going with this already now, because voltage is the energy per charge. But carrying on. Okay, if we rewrite it in a easier to see manner for most people, joules over seconds is joules per second, and we kind of form a pseudo equation which is a units equation, coulombs over seconds, and then we've got multiplied by joules per coulombs. So you can see when you multiply this out, the coulomb part is going to cancel and you're left with joules per second. That just gives you a proof that current times voltage is the same as the power. Okay, so that's our nice little units proof. Same way you can do the units proof with Newton's second law, showing that F equals ma is the same as change of momentum, equaling the force times the change in time. Now I want to give you an alternative equation, or alternative equations. We know from Ohm's law that V equals I times R, or rearranged, I equals V over R. So if we take these two equations, we can change our P equals I times V into alternative forms. So you might see I equals V over R, which is your current part of the formula, times V, which gives us V squared over R. So P equals V squared over R. You could also see it as P equals I times IR, which is taking our IR value for V and substituting it in. And that gives us I squared R. So P equals I squared R, P equals V squared over R, alternative forms of the power equation. And you've seen that units prove this equation to be true. Very cool.